Bismillahirrahmanirrahim. Welcome to subsection 3.2.3 context switch. So when an interrupt happen, we need to switch the current process to another process, because remember we talk about multiprogramming. So in multiprogramming, we don't want the CPU to sit idle. So if the interruption happen in the current process, so we need to switch to the new process. Okay, so how we are going to do that? Okay, so when the CPU switch to another process, first the system must save the state of the old process. Okay, and load the saved state for the new process via a context switch. Okay, context of a process, okay, is represented in the PCB. So this including, okay, when we want to change when we want to switch from one process to another process. So first we need to save the context of the processor, including program counter and other register. We also need to update the PCB of the current process in the running state. Okay, whether it will change to ready state or block state, waiting state or exit state. Okay. So other relevant field that must also be updated, including accounting info. Okay. So all the context of process are represented in the PCB. Okay, we look at this figure. Okay, so let's say we have two process here, P0 and P1. Okay, so now P0 is executing on the CPU. Okay, and suddenly P0 has an has interruption. Okay, or maybe system call. Okay, so what happened? OS will save state process P0 into PCB0. Okay, so after some time, okay, OS reload state from the new process, which is PCB1. Process P1. Okay, so operating system will reload state from its PCB, which is PCB1. Okay, so now process P1 is executing on the CPU core. Okay, so after a while, it has interruption, or it made a system call. Okay, so again, OS will save state process 1 into PCB1. Okay, after some time, okay, operating system reload state from process P0, which is reload state from PCB0. Okay, now process P0 is executing. Okay, so this is this figure explain how the context switch occurs in the CPU. Okay, context switch time is overhead, meaning that the system does no useful work while switching. Okay. So the more complex of the OS and the PCB, it will takes longer time for context switch. Okay. So time dependent on hardware support, including memory speed, special instruction. Okay, a set of register. Okay. Okay. So for example, let's say the hardware provides multiple sets of register per CPU, meaning that we can load multiple contexts at once using a special instruction. Okay. Okay. So typical speed of context switch, okay, is several microsecond. Okay. Right. Thank you for watching, guys.